All right, let's now solve ODEs using integrating factors. So our goal here is to solve ODE of the form y prime plus a constant y equals f of t. And soon we'll do a more general form. So for instance, let's try to solve y prime plus 2y equals e to the t. And what's the idea? The idea is we want to multiply this differential equation by a clever function called an integrating factor and put this in the product rule form from the previous example. And so here is the trick, and later I will prove how this trick works, so in a separate video. So let's multiply by this ODE by, so the helper function in this case is e to the 2t. And this helper function is what's called the integrating factor. So let's do that. So we have y prime. So let's do e to the 2t, y prime plus 2 e to the 2t, y equals e to the t times e to the 2t. And notice you can already see by doing that, the left-hand side becomes a derivative, because this is like fg prime plus f prime g. So this left-hand side just becomes e to the 2t y prime. And that becomes, the right-hand side becomes e to the 3t. So just as before, we can just solve this by integrating. That's why it's called an integrating factor. Da-dum. Then we get e to the 2ty is integral e to the 3t dt, which I like to remind you, an antiderivative of e to the 3t is 1/3 e to the 3t, because when you differentiate e to the 3t, an extra 3 comes out. So we want to do the reverse. And of course, plus c. And then what we get is y is e to the minus 2t times 1/3 e to the 3t plus c. And so y, to simplify, becomes 1/3 e to the t plus c e to the minus 2. So in summary, how do we know what integrating factor we pick? Well, here we had, I think, y prime plus 2y equals e to the t. In general, for y prime plus ay equals f of t, just multiply by e to the at. So before e to the 2t, now e to the at. And to remember that, just think of the most delicious function, which is to eat.